So in the past few months, I've been working on this retro FPS, which started out as a Wolfenstein-style software render, became a Doom-style software render, at the end of the last video looked like this, and now looks like this. The entire thing is written from scratch in C with only a couple of low-level dependencies, programmed as God intended. But since there's been about this many commits in between this, and I made the very wise decision to give all of those commits near meaningless messages, here's my best attempt at explaining what I've been up to for the past 4 months and how we got here with beautiful, dangerous C code. So up until now, everything in the levels has been made out of perfectly perpendicular planes. The walls are straight up and down, and the floors and ceilings are perfectly flat, which is totally fine for a Doom-style game, but I was getting really tired of building out stairs in the level editor that I'd programmed and really just wanted to be able to slap down a ramp and call it a day. Also, since the last update, I've played a bunch of Quake and have been getting really jealous of the level design flexibility that it had. If you take a look at Quake though, and you look at its level editors, they're far more complicated than the primitive 2D editor that I've made in order to make my levels, and I didn't want to abandon it just for some fancy angled floors. So I needed to come up with a solution that would let things stay in 2D. So since we currently have these sectors just made up of a bunch of sides, I decided that each floor and ceiling could pick a single sector side to pivot around and then define an angle, theta, to rotate vertices by relative to that side. Then if we just whip out the tangent function and do some math to equate it to dy over dx, dy being the vertical z offset of each vertex and dx being the distance from the pivot side, we can compute the z difference needed for each vertex in a big fancy function that looks like this, but which really just boils down to that tangent math. With the quick UI thrown together in the editor, here are our slopes at work. Better than manually adjusting things though, I also added this reach tool which uses the same equation as before, except it solves for theta to get some height difference dy. This way we can calculate the angle which a plane needs in order to align it with a nearby floor or ceiling, which makes building those ramps very easy. Just check out the wireframe updating in real time as I adjust the angle. That all covers the rendering side, and movement on slopes was another issue, but with some velocity scaling and updates to take the actual plane normals into account instead of just assuming that every floor and ceiling was flat, we can get movement working and see that some test grenades that I added are bouncing around properly. Using our new slope tool, I built out a brand new test level for us featuring some pretty fancy arches. With the new level design, I added in some really simple AI so that we can have these dudes of various colors who try to attack us as we shoot them with the handgun. I was also able to get doors and buttons working, which you'll be able to see here as soon as I get through these blue guys here. The buttons and doors are hooked up through a simple tag system where two objects in the level editor just need to share the same integer tag and then they can communicate with each other, and then the platforms move by attaching an actor function to the sector when the tag changes, which is just some callback that gets slapped in a big linked list of functions which run every game tick, which in this case can move the sector floor or ceiling up and down. The actor idea I kind of just yoinked from the way Doom does things. At this point, now that I'd introduced what is tantamount to sacrilege in the world of Doom-likes by adding slopes, I felt the game was in this weird late build engine style limbo where it wasn't quite as basic as Doom now, but not yet as fancy as Quake with the true lighting, fully 3D levels and models, so I decided I needed to get off the fence and just Quakeify this whole thing, starting with lighting. So as of now, lighting is probably the ugliest part of the game. Even though I'd experimented early on with Quake-style light maps, I decided to go the simpler route and do some retro sector-based lighting where each sector only has one light level that can just be tweaked in the editor. This can produce some okay results, but things can look pretty flat and boring. So to get things looking properly Quakey, we need actual light with actual shadows. Now, the trivial solution would be to do real-time lighting with shadow mapping for everything in the level, but this wouldn't be great for scenes with hundreds of lights, and it doesn't make a ton of sense for levels with mostly static geometry and just a few moving platforms here and there. So the next obvious solution is to do something like Quake, where lights are placed inside of a map editor and then lighting is just baked into the map file. This is effectively what I'd done in my initial lighting experiments, and it worked just fine there, but this adds a nasty pre-processing step that would get in the way of my all-important minimal turnover time level editing flow, and it would only get worse as level geometry got more complex and we added more lights, so this was also out. So I started thinking back to my old robot plant game where I just raycasted through the voxel grid in order to get pixel perfect shadows, but doing some back of the napkin math about voxelizing the level, it turns out that voxelizing a reasonably sized level like this with reasonably sized voxels would be way too big of a task to do effectively in real time with reasonable memory usage. But raycast lighting maybe wasn't such a bad idea, so what if I could just raycast through all the walls in the level instead of some fancy voxel structure? I had already divided the level into these convenient blocks of walls for collision purposes, so if I could just get that data uploaded to the GPU, then I could just raycast through that. So after marshalling the data a bit and packing it into an image so that the GPU could read from it, I wrote out a GLSL DDA, or Digital Differential Analyzer line drawing / grid traversal algorithm to traverse the data, which is, funnily enough, the exact same algorithm that was used on the very first version of this entire project, the Wolfenstein style render. Just this time we're traversing these blocks of walls instead of, an entire level only made out of blocks. With that working though, I threw together an initial test with one single, floating, moving, real-time shadow casting light. And it ended up looking pretty good, and because it's all done in real time, everything updates seamlessly with the level too as we adjust things. I know that I'm cheating a little bit from the Quake approach too, since my computer is a few orders of magnitude faster than the computers running Quake back in the 90s, but hey, I'm not planning a 486 port of this anytime soon. With our proof of concept in working order, I really quickly and sloppily deferred the render and then slapped about 100 extra lights into our scene to test it all out. Those lights weren't shadow casting just yet though, since things still needed a little bit more optimization before we could do that. Since we want to avoid doing real-time raycasting for every light every frame, especially in areas with completely static geometry and static lights, I also came up with a neat way to store shadow information between frames. Since the levels are still specified on a 2D grid, even though we do have our fancy slopes now, our levels have this neat property that for any given 2D XY point, there's only one visible column of Z-space. Which, to give a visual demonstration, means that level geometry like this is not possible. Which also makes sense if you consider it from the 2D perspective. Our level editor has no way to express geometry like this. And while some may call this a limitation, I call it an opportunity. Instead of saving a 3D cube shadow map for each light, we can just exploit this fact about our level geometry to save the lowest and highest visible Z coordinates for each shadow map pixel for each light. With some reasonable bounce clamping and intensity information mixed in, this system produces textures that look like this, where we store in the RGB information the lowest visible Z coordinate as red, the highest visible Z coordinate as green, and the intensity of the light as blue. With our bespoke shadow map system programmed in, I added a new drop-down menu into the level editor so we can easily control all of these parameters and customize the lights to our heart's content with colors and attenuation. Putting these fancy lights throughout our test level, which you've probably also noticed has gotten a bit of a reskin, things look like this now. And you might also notice that things are a little more jittery than before, so allow me to explain that too. With the inquakening of the game in full swing, I needed to draw the line somewhere, and that somewhere was going to be with this awful bilinear texture filtering that a bunch of these late 90s, early 2000s games had going on, which I think kind of makes them look like sludge, ignoring the nostalgia factor. And this might be a hot take, but I don't want my game to look like sludge, so I decided to go in the exact opposite direction of these games and lean into the pixelated look. To do this, I added a shader effect which I've decided to call Dancing Dither, or as video compression algorithms call it, oh my god, what have you done? Please go. And it's what's giving this fancy little jitter effect to everything. Since dithering is usually done with some sort of per pixel offset value, all I did was take that value, fix it to each 1/32 of the world, and then shift the offset around a bit over time. The effect is subtle, but I think it does a lot to make the game more interesting to look at. I also took the same effect and applied it to shadow edges, which as a bonus helps out with hiding any little errors that might occur in the edges of shadow maps. So with all that in place, here's a new and improved run through of our test level with some notable upgrades in addition to the shadows and dancing dither. I added particles on everything, made it so that you shoot lasers now instead of using that handgun, added a grenade launcher that kind of looks like it shoots lemons, made it so that the test tubes explode into colorful little drops, and I also experimented a lot with the AI on our colorful friends here. Some of them got a little too much health though, as you can probably tell with this big red guy. I also experimented a little bit with these turrets, which are just some hanging eyes that shoot fireballs at you. Oh, and don't pay any attention to the eye up there. It's going to go away in a second and make a comeback later on. Anyway, with things coming together gameplay-wise, you can probably tell that I was avoiding sprite work. I mean, just look at the enemies. So that was the next problem that I set out to fix with 3D models. So to get 3D models working, I started by just specifying things in code and shoveling all of the vertices for each model to the GPU each frame. And after that, I wrote a quick OBJ format importer for plain text models so I could import some free weapon models and some of my own Blender abominations. What I really needed though, since rotations can only get you so far, was 3D animation. Specifically skeletal animation, where meshes can be controlled by a set of bones which tell each part of the mesh how to position itself at each frame in an animation. As I wasn't interested in doing all this 3D math to compute how everything needs to get transformed, I decided to take the dumb and simple approach. I already had an OBJ importer, so what if I could just get Blender to export all the frames of each animation as individual OBJ files, slap all of those files together into one mega file, and just import that into the game. That way I don't need to worry about bones, because there aren't any. There's just raw plain text vertex information, file size be damned. So I dusted off my Python skills and hacked together this absolutely disgusting Blender script which does the whole OBJ file concatenation process and spits the data out directly into the models folder of my project. And just like that, I had my own bespoke model format. With all of this implemented and a quick little lookup system that lets me specify model names, animations, and animation frames as strings, we have this guy walking. Or whatever you might call this sort of sliding as it moves its legs motion. Let's just put him out of his misery here for now with our fancy new fully 3D weapon. After a little more blendering, I also added these big pulsating nerve-like things, which don't do anything yet, but they do look pretty cool. Among all of the other random test things that you can see here, like this debug info down here, I also added liquids to the engine, this green stuff here being called pain juice because, well, it hurts you. And now there are also these little dust-like particles flying around that just add a little more visual spice to things. With yet another test level redesign, I also added a chromatic aberration effect which intensifies with distance. This works by just offsetting the way in which the red and blue channels are sampled according to each pixel's distance from the camera. I think it adds a bit to the surreal look that things are starting to take on. So with the visual style of the game more or less in place, let's hop into the future by about 100 commits or so and let me show you everything else that's changed with gameplay since last time, as I did promise gameplay in the comments of the last video. So let's start by taking another look at the test shotgun. I spent some time tuning the exact feel of the weapon to see what I liked the best and juiced the shotgun fire mechanism up with screen shake, a slightly blinding amount of flash every time that you shoot, a reasonable amount of kickback, and the ability to shotgun jump, because I thought it could be a fun way to traverse levels. This is among a bunch of other weapons which I've tested, including a knife, a pistol, a minigun, that lemon grenade launcher from earlier, and this bolt-style projectile thing. But the shotgun remains the primary weapon for now. Even though I do kind of miss the minigun sometimes, its lasers would bounce around the level, and that was pretty fun to play with. For reloading though, I was inspired by Game of the Year 2022 Cruelty Squad, where you have to physically move the mouse in this downwards motion in order to reload. I didn't want to copy this outright though, so I kind of expanded on the system by making one where the player has to hold down the reload key and then quickly draw a pattern specified in code as a series of points in order to reload each weapon, which then gives a little click, a tiny flash on the screen, and a nice little rotation animation. It might seem a tiny bit unintuitive, but I promise that you get used to it quickly. After reloading, I added our friend the eye back in, this time in full glorious 3D. First off looking a little bit like a spinning little meatball, and then getting more recognizable with the texture. The player holds it in their left hand, and while right now it kind of just looks around randomly, it will start looking at different things as the player passes by them in level, maybe guiding them to secret areas or hidden doors. I'm thinking as well that it's going to get some sort of alt-fire mechanism which can be switched out with items that are picked up in each level. As you can see on the eye here too, as it chills out and floats upside down, I also added in this PS1 style vertex snapping effect by rounding model vertex coordinates in view space. Also, after a lot of different UI experiments, I ended up just painting the numbers the player needs to be able to see onto each hand and the eye, with the stamina over here, the ammo over here on the weapon, and then in place of numbers on the eye right now, it kind of just ominously says life, but that will probably change soon. The camera got some juice as well, which was added incrementally throughout all of the updates, but let me round up all the changes here. First, I made it so that the FOV increases slightly according to the player's current speed, or more specifically the dot product of the player's 2D velocity and the look direction of the camera. There's also a pretty steep camera tilt applied when the player is moving in a direction perpendicular to the current view vector, and some slight view bobbing, which I know is controversial, but I'll include an option to disable it, I promise. After that, I added in a sliding motion, which lets you slide down surfaces and also slide tackle enemies, and I emphasized it with these chromatically aberrated speed lines that fade in and out as a shader effect. Later on, I also added a dashing movement where time slows down and you dash in the direction that the camera is facing. After initially testing this out, I thought it was pretty confusing, so I thought the slow-mo could give the player a little bit more time to react and aim after each dash. This was basically just done by scaling the global time delta down by some value to get things to move around at a slower rate. I also ended up adding a slow-mo bonus both when enemies are bonked by a dash and when they're popped up by a slide tackle. I also experimented with visual feedback in the heads-up display, as you can see by these pop-up messages you probably noticed. I'm not sure that these text pop-ups are going to stick around though, but I think they fit okay with the slightly surreal vibe of things. It also matches well with the system that I made where arbitrary text can be painted on walls just by editing a big list of strings in the map editor. I called these vtexts internally. This will be used to guide the player through levels as well as give hints, since I also added a toggle to make the text overlay only visible at close distances from the camera. I think the lore idea in my head right now is that it's the eye who is reading them. You may think this text on a lot of things vibe is a little lazy, but I just call it visual flair. Skimming over some updates on the AI for all of these guys, which basically just got implemented as state machines. I also added teleporters, which are implemented as a liquid called teleport juice internally, but trust me, this was the easiest way to get things done. Basically, you can just hop in and fall for a while until you get spit out at the exit teleporter with a matching color, specified in the level editor, of course. And no, don't ask how you fall infinitely. I definitely did not do this by just teleporting the player a few units up over and over and over again while they fall. And if you say that you can notice it in the gameplay footage, you are lying and I don't believe you. There are also inter-level teleporters which allow you to change entire levels by just writing the file name in the level editor. The teleporter then just seamlessly swaps out the level in a few milliseconds at the end of the teleport, and it spits you out in the new level with a fancy particle effect. A nice perk of being on my own engine and controlling the entire level loading scheme, so I can always make sure that this takes a maximum of a couple milliseconds. These types of teleporters will be used to make a big central hub level to make moving from level to level in game completely seamless. Speaking of level design with teleporters though, the map editor also got a lot of really important updates which will allow me to quickly iterate on levels. First, I made it so that textures can be previewed for materials just by mousing over them, which is huge for testing out different textures on an environment. I also added 3D mouse interaction for moving and scaling textures on walls and planes in the 3D view. In addition to that, I threw together a find tool to find various level objects by ID because I kept getting lost in my levels, as well as a bookmark system, which lets you remember specific parts of the level and hit a key to cycle between them in editor. I also built a shift tool to move large parts of levels in 3D space, since sometimes when you would select a bunch of things and drag in the editor, it would just crash, so this is a neat little workaround for that. And finally, there's this very important rotate tool, or as I like to call it, the shit I built this whole level and now I want to rotate part of it 90 degrees tool. It's still a little janky since it always has to rotate around a bookmark, but it does its job well enough and I can adjust things by hand afterwards. Generally, I'm trying to put a lot of work into the map editor as well, so that when the game does eventually get released, you all can use the map editor and it's not just some arcane, poorly documented internal tool. As far as gameplay goes, I've taken a more experimental approach with different mechanics and good stories that can map onto them, including adding a timer to levels, making it so that you need to reach the level exit in a set amount of time or you explode, paying to open up new parts of the level which get laid out in a very confusing way with the portals. This also involved copying and appending entire levels and rooms to the current level at runtime. I also worked on maybe making a horde mode style of thing, which was fun in playtesting and also a very good stress test for the engine, but I don't think I'll keep it. And there are also a bunch of different enemy behaviors that I prototyped, so just to mention a few, there are the invaders from earlier, these hands here called crawlers, turrets, which currently just rotate and spam fireballs, they're a little bit OP right now, phantoms, which are still just cubes and they also just rotate and spam fireballs, but they're a little easier to deal with. There are also these spiders, which were really fun to play with earlier in development, but I haven't quite updated them to be 3D, and their AI is very broken at the moment. But I'm sure there's a place for them in the new pantheon of enemies. I also modeled these mouths, which open when the player is near them, so you'll be able to feed them with the jibs from larger enemies to open doors as a sort of lock and key system. Because I didn't want to have a classic colored keycard sort of deal. In order to feed them, I need to create a pickup system with physics, so I made these small moving blob things for you to pick up and move around. They're also quite fun to just yeet into the teleporters. These are just placeholders right now though, since I haven't had the chance to implement any large enemies with big fleshy jibs yet. With the base game look, feel, movement, and gunplay in place and everything feeling pretty fun, we'll be working out more story and design specifics next time, especially around how and why the player acquired the eye, why there's text on everything, why these guys look so strange, and, well, everything else. As I do move into level design though, and maybe some of the less technically interesting parts of development, I may work on some smaller side projects here and there, so that maybe there isn't such a long gap between uploads on my channel. So expect some of that while I work on this simultaneously and update whenever something interesting gets added. And I can remember what it was from looking back at the commit message. That said though, thank you very much to every single person who's chosen to support me on Patreon. Feel free to check out the link in the description if you want to join and get access to the Discord, source code, future demos and playtests, or you just like my videos and want to support me. And an extra special thanks to the top supporters of my channel, Alex Pegg, Coop, and Henry M. And as always, thank you very much for watching, and I'll see you next time. Definitely sooner than 4 months from now.